So we're practicing with these increasingly complicated common denominators, and the idea that if you have a denominator which is factorable, you should factor it, because you might find out it's more closely related to the others than you first realized. Now they're starting to give us trinomial denominators, so the factoring is getting a little sporty, but we should still be able to manage it. This piece, 2 over x plus 1, is already as factored as you could hope for, so I'm not going to change anything about that. But down here, this trinomial, we're trying to find two numbers which add up to -2 and multiply to -3. I believe x minus 3 and x plus 1 will do the trick there. X squared plus x minus 3x, check, and minus 3, yep, that works. So now that we have that, we look at our denominators, and we can see that this one contains an x plus 1, and so does this one. That wasn't obvious when it was first written, but now that it's factored, we can see we don't need to do anything about that x plus 1. It's already contained in both fractions. What we do need to change is that the second fraction contains x minus 3. This first one does not, so we'll give them 1. There's an x minus 3, and to keep everything balanced, we put 1 in the numerator as well. So now we can combine these two fractions. They have the same denominator, x plus 1, x minus 3. And in the numerator, we get 2 times x, 2 times -3. Now watch out. This negative sign applies to everything in this fraction. So we're going to get minus x, and we're going to get minus 1, which of course I'll write as plus 1. Now we collect like terms. 2x minus x leaves just 1x. Minus 6 plus 1 makes minus 5. And downstairs we still have x plus 1 and x minus 3. This clearly cannot be factored any further, but do check, because you never know when one of these is going to have a common factor that you can exploit. As it is, that is our simplified form. Notice they finally gave us a break from this state the non-permissible values thing that we've been doing for a long time now. I guess they figure we've got the idea. Just as a quick check, in case you're missing it, the non-permissibles here would be -1 and 3. This bit, now we have both of these to factor. The first one, two numbers which add up to -3 and multiply to 2, I believe will be -1 and -2. And in the second fraction, we need them to add up to 1 and multiply to -2. Y plus 2 and y minus 1 ought to do it there. Y squared minus y plus 2y and minus 2. Yeah, that looks good. So, what do we need to add here? This fraction has a y minus 1. So does this one, so no change required there. This fraction contains a y minus 2, so the right-hand fraction needs 1. This fraction contains a y plus 2, so we need to add one of those here. And this fraction contains a y minus 1, got it. This one contains a y minus 2, and obviously we have that. That's where it came from in the first place. So, our new improved fraction, when we combine these, will contain y minus 1, y minus 2, and y plus 2 in its denominator. And upstairs we get 1 times y, we get 1 times 2, we get 3 times y, and we get 3 times -2. Combine that, 4y, 2 minus 6 is minus 4, over y minus 1 and all the rest of it. Are we done? We're not, because this numerator is factorable. We can pull a 4 out of it, which leaves us with, hello, y minus 1. You see how we can take advantage of that? This expression already contains a y minus 1 in the denominator, which means we can cancel these out. Y minus 1 there cancels y minus 1 there, and so our finished result is 4 over y minus 2, y plus 2. Done.